Okay, hello everyone. Today's session we discuss module 5 to 6. This is the checkpoint, two modules, STP and Ether channel. STP dealing with blocking redundant links, therefore stopping my layer 2 loops, then Ether channel bundling links, therefore creating a way for us to have more bandwidth and at the same time having redundancy. Question one. What additional information contained on a 12-bit extended systems ID? The systems ID has the bridge ID, which consists of the priority, the MAC address, and the additional information of the VLAN ID. That is what is the extended system basically. It now has the addition of the VLAN ID. I think that's theory two. During implementation of STP, switches are rebooted by the network admin. What is the first step of the spanning tree election process? The first step is exchange of the BPDU messages. So we have the exchange of BPDU messages, then we go to election of who becomes the root bridge. Then we elect Mapotedu root ports or designated port. Then from there, we have the alternate port and the blocked link soon after. I think basically those are the steps, starting with exchange of BPDUs. Before election, we exchange my BPDUs, which contains information equity, my bridge IDs, I say. Then that information is then used to find the root bridge. So from our answers, B looks like more of an answer. Okay, all switches send out BPDUs advertising themselves at the root as the root bridge. Then pause it for election. They do advertise all of them, but panels it for election. Then one is chosen with the lowest priority. All right, 3 STP raw adopted by switch where there is no other port with a lower cost to the root bridge. The root port is the port which has the lowest cost to reach the root bridge. I think through the sessions that we did for STP, this was clearly covered. What is the root port? What is the designated port, etc., etc. Question 4: which two concepts relate to a switch port that is intended? Um, which two concepts? Let me disable waiting room. All right, which two concepts relate to a switch port that is intended to have only end devices attached and intended never to be used to connect another switch? So on this question, we can use a technique eliminating my answers. What we are trying to find here is a switch port, concepts that relate to a switch port. A is not a concept, it's a concept that relate to a switch port, the bridge ID. The extended systems ID, it has nothing to do with the switch port. Per VLAN, spanning tree has nothing to do with the switch port. It's either you know these are the two answers, or you can use a method of eliminating by also knowing that the bridge ID has nothing to do with the switch port. So those are the two concepts that relate to a switch port intended to have only end devices, port fast and the edge port. Right. Which three concept components are combined to form the bridge ID? To form the bridge ID, we have the systems ID with the VLAN, we have the MAC address, then we have the bridge priority. These three is what makes up the bridge ID. So this one, I think we already answered the question on this one. This is mainly the VLAN ID, which VLAN specific interfaces belong to. Question 6, match. So this one, I can see it was already matched. I think we can skip this one. Which two port states does the switch lane MAC addresses and process BPD use? Here we don't learn MAC addresses. Listening, we don't learn. We listen. Blocking, we don't learn. We learn MAC addresses during forwarding and the learning part. So I think the learning part, you definitely have to get it right. Then the other part, when we are forwarding, we continue learning about MAC addresses. Number 8, if no bridge priority is configured in prevalence pairing tree, which criteria is considered when electing the root bridge? The root bridge is chosen depending on the ID, on the priority, the bridge priority. Okay, the bridge priority is here. It is the same. Therefore, we go for the lowest MAC address. So those two things. To elect the root bridge, you can either go for the priority, bridge priority, which is sometimes equal if it is left at default. We can change it. If you have a lower bridge priority, then that one automatically becomes the ID, the root bridge, I mean. But if by default, all of them, they are the same, then we go for the MAC address. We definitely cannot use these two. It's not the highest MAC address, it's the lowest. Match. Okay, that match was already done. Let's go to number 10. When the show spanning tree VLAN 33 command is issued, 3 ports are shown in the forwarding state. Which 2 port rows could these interfaces function while in the forwarding state? 2 port rows could these interfaces function while in the forwarding state? Right, pinda yetu. Mvunzo uri kubvunza kuti kudii? What is the question asking? My brains are thinking. I'm gonna ask a question. Let's chip in. Okay. For this one, I think I can look at port rows which are in forwarding state under in normal circumstances. We have port rows which can forward. So I can remove this block state and disable it. They definitely cannot forward anything. Then I think alternate cannot forward anything as well.
The alternate, yes.
Yeah, so these two are definitely 2 port rows which can forward. Question here, the way it was, I think Chirungu may be answering question, but I think they were trying to ask of port rows that can forward, that can be in a forwarding state. I think that was what they wanted to ask, but Chirungu did vary, but we continue. I think that's very important as well. You need to be very good at understanding what the questions are asking. All right, question 11. What is the function of STP in a scalable network? STP decreases the size of a failure domain. It protects the edge. It doesn't protect nothing. Combines multiple switches, multiple switch trunk links to act as one logical link. This is Ethernet, Ether channel, I mean. By elimination, we have our answer D. STP disables redundant paths to eliminate layer 2 loops. That is the main function of STP. Question 12. Characteristic of spanning tree enabled by default. I know, yes, it is enabled by default. It is used to discover information. It is not used to discover anything. Uh, Here we have LLDP and no, and CDP. I think so. But for Cisco, this is the Cisco one. It is a TTL, time to live. Time to live is not a mechanism on layer two. Um, that's where the answer is wrong anyway. It prevents propagation of layer two broad broadcast frames. Yeah, this question again. I think there was a point we revised this, and I said this could be an answer as well. If you remember, why wasn't this an answer? I once saw this question. Why is D not an answer? Characteristic of STP. Does it not prevent broadcast frames, propagation of broadcast frames? You can unmute Tikun's way, Farai. I can see Lloyd. I can see Sharon. I think Sharon there has a answer before, if I remember well.
It's because Zichi, the last time Tanzania had a broadcast storm.
That was the thing. Takaita answer yedu takaita broadcast storm, but that answer correct. It happens in exams. It happens. But that was the wrong answer, obviously. The correct answer is spanning tree is enabled. STP is enabled by default. 13. Which spanning tree standard supports only one road bridge so that traffic from all VLANs flow over the same path? Per VLAN enable multiple bridges. I think we discussed something to do with multiple instances. Definitely meaning you have multiple road bridges. Per VLAN, for every VLAN, there is a bridge. This is multiple. This is per VLAN, meaning there is multiple as well. So this one, if you didn't know the answer, you can use method of elimination. But this one is the OG STP, one instance. Right. What is the purpose of STP? Creating smaller collision domains? No. Preventing loops on a router? No. Yeah. It's a switch up or it's an answer very correct, but that's a no. There's a router there. Preventing layer two loops. Preventing routing loops. Yeah. Preventing loops only. Yeah. Answer is C here. Preventing layer two loops. Allows the Cisco devices to exchange routing, create smaller broadcast domains. Definitely a no. What is the value used to determine which port on a non-root bridge will become a root port in an STP network? The cost. This one. The cost is the value which is used to determine which port becomes the root port, and the port which has the lowest cost to get to the root bridge becomes the root port. So the path cost is what is used. The highest mark, the lowest mark, the VTP. This, do you know what VTP is? I know where what is VTP. Hello. What is VTP? I think in this, we don't have, there was no discussion on VTP, but that's the, is it not the VLAN trunking protocol? VTP. What is VTP? Then proof of the denial Mango, and I'm drawing some blanks. It should be VLAN trunking protocol. DTP. What is DTP? VTP and DTP. Quick search. Keep your answer. Okay, the answers I'm get is VTP, yeah. VLAN trunking protocol. Then we have the dynamic trunking protocol. I think my brains were correct. Yeah, VLAN trunking protocol. CCNA, I don't think they did VTP, but I think it also gets you to see how networking is very broad. As much as CCNA has a lot of things, there's also a lot of things which were left out. One of them, the VLAN trunking protocol, we didn't discuss that at all, but it exists. It's there. Continue. Refer to the exhibit. Which switch will be the road bridge after the election process? Election process here uses the priority. First, the lowest becomes the road bridge. And I can see my priorities here, they are the same at 32,769. Therefore, we use the MAC addresses, the lowest one. In the lowest one, I can see we have 311. Is this not the lowest? I think that one is the lowest. 3133 31. So our answer is switch 2. This is the lowest MAC address. Quick question. If you read correctly, there was something to do with this value here, the bridge priority. And they said the bridge priority it should go from a value of 0, incrementing with the value of 4096, and we have multiples of 4096 as we go. And the default is 32768. Confirm. Bruns research that video. Hello. All right. Understood. Right. Then, where is the 32769 coming from? You can unmute. That's so that we move quick. Those are the values of bridge priorities: 0, 4096, then multiples of 4096 as we go, including 32768. I think let me check 32768 if it's a multiple, just to confirm. 32768. Yeah,
32768, according to what was in the notes, was the default. We mentioned default bridge priority.
Yes, that's correct. That's exactly what I said. But I'm asking, why do we have 32769 here? Abvepi, panapa default here 32768. And is this a multiple of 4096? I think mukadzokera literature yenyu, manotes yenyu, you see a lot of this number. Which is default. But is it not 32768? That's the question I'm asking. I'm not one.
What to explain it, Papa, in that what I seek.
Rasika papi.
But 32769 now.
But myself one. No, I gave you background context yekuti ndikubva nekupi ndati ma-values enyu ema-bridge priorities muma-notes menyu course material inotaura that value can be 0, 4096, then multiples of 4096, and tataona kuti 32768 is a multiple of 4096. So from 4096 we have 8000 what times 2 4096. Those are values of bridge priorities. But when you go to some of my values, Parubuda, comrade, 32769. Why? Did you not ask yourselves why? You should have. Because I think
Yeah. Inini ndakambozvibvunza kana ndanganyeba.
Pari pachangu pane pandakambozviona zvakanyorwa but now forgetting kuti painzi kudii.
Right, it has to do with the extended system ID. The extended system ID 13H, what does it give us? What is the additional information? Extended systems ID, what additional information does it provide us with?
MAC address.
Yeah. Heba.
Ndarasika.
Chibaba right. The 12-bit extended system, I think that was the first question I read. What additional information does it provide us with? The bridge ID, right? The bridge ID is made up of 3 components. That's another question we answered. The bridge ID is made up of the MAC address. It is made up of the bridge. Is that bridge? This is bridge priority. It is also made of the extended system ID. What is the extended systems ID? That's what it is. That's what it is. Let me go back. Question number 1. Question number 1. What additional information is contained in the 12-bit extended systems ID of a BPDU? The additional information is the VLAN ID. Right, going back to our question now. It means Panapa, we also have the VLAN ID, the extended system. So this value here, E in a chance is a value which uses the extended systems ID as well as the bridge priority. So value A, nobody said the sum of these two, the sum of the bridge priority and the extended systems ID, which is the VLAN ID. So bridge priority yedu inenge 32768, VLAN ID yedu by default inenge 1, which gives us a value of 32769. Right. I think it's wise to write some of the things then you sit down and you really look to see the truth to be. Like things like what components gives us the bridge ID. I think you should have wrote that down. What is the extended systems ID? Those small little things. Right, let's continue. What are the two drawbacks to turning STP off and having multiple paths through the layer 2 switch network? So if we have redundant links, we create loops, broadcast storms, congestion, unstable MAC address, table, things like that. So I'm looking at this is not an answer. This is definitely one of the answers we have. MAC address table becomes unstable. Then port security becomes unstable, nothing to do with port security. Broadcast frames are transmitted indefinitely. That could be an answer. But is it? Port security shuts down all the ports that you have attached. Definitely. By elimination, choose 2. Those are the 2 answers. Question 18, a small company has 6 interconnected layer 2 switches. Currently, all the switches are using the default bridge priority value, 32768. Which value can be used to configure the bridge priority of one of the switches to ensure it becomes the root bridge in this design? Which value can be used? Tipe answer, give us an answer. So those are what I want to discuss. So by default, data route, the value is 32768. Data route, my values can range from 0, 4096, then times 2 times 3, multiples of that. Our answer here is A, VLAN ID. Yeah, that one is lost again. Yeah, this is not an answer, definitely not an answer. The question, you good. Let's look at this. The question, you good. In a 6-ma switch. Another answer here, apana VLAN ID. The question is in a 6-ma switch. 1, 2, 3, 4, 5, 6. My switch SI, priority value is default. So, which means my switch SI priority value is 32768. They're asking, we want to elect a root bridge. Which value can we use from amongst other people to have a root bridge? We cannot use the VLAN ID. No, we cannot. I'll put my questions here. Why am I answering? Answer away, upon answer away. All right, pane away. B. All right, Lloyd does any B. Why B? The answer here is a value which is a multiple of 4096. So let me see. The calculator here again. And I piece. The answer here is a value which is multiples of 4096. So the answer is going to be 28, 6, 7, 2 divided by 40. Yeah, that's an answer. This one cannot be the answer because that's the default one. Probably these ones are not answers because I asked for multiples of 4. Yeah, you can confirm, not multiples of 4. Continuing. Now to other channel. Refer to the exhibit. Questions and refer to the exhibit were the most difficult for me. Pandai fambana ya CCNA. Again, be tricky. Kif ne multiple answer questions. Those ones are tricky as well. The administrator tried to create an ether channel between switch 1 and the other 2 switches. Yeah, that's where the problem is. What is the problem? The problem is you cannot create a multiple ether channel on one switch. So here you cannot have this as an ether channel, this is a different ether channel on another switch, and not this one. So ether channel shine this sort of point to point. So you can either have a switch and a switch, then you create your ether channel here. You cannot have the same switch now creating another ether channel with another one. You cannot do that. I want you to answer the question why when you revise. It's simple logic, actually. You cannot do that. So let us see the answers. Traffic cannot be sent to 2 different switches through the same Ethernet channel. Traffic cannot be sent to 2 different switches, but cannot be sent to 2 different switches, but only to 2 different devices like an Ethernet channel enabled server and switch. Traffic can only be sent to 2 different switches if the Ether channel is implemented on which answer speaks to exactly what I said. Badanza Chirunga. You cannot have multiple Ether channels on one switch. So this is an Ether channel. This is another Ether channel. You cannot do that. You can only have one. meaning this one and only this one. You cannot have this one as well. So traffic cannot be sent to two different switches through the same ether channel link. This sounds like guys. Traffic cannot be sent to two different switches. Yes, but only to two different. It cannot be two different devices. This is false again. Traffic can only be sent to two different switches if ether channel is implemented on Giga. No, whether a Giga or doesn't matter. Traffic can only be sent to two different switches if ether channel implemented on layer 3 switches. No, our answer is that one. Ether channel for you. All right, let's go. Which statement is true regarding the PAGP to create ether channels? The session we did for ether channel, I think it was very small. And we focused on PAGP and LACP. And I tried, I think, explaining what's the difference between those two protocols. Which statement is true about PAGP? It requires full duplex. Is that true? It requires both ends to have the same duplex settings. Half duplex can still work. It increases the number of ports. No ports are increased. It requires more physical links. It mandates that an even number of ports, we can use 3 ports we can aggregate 3 ports, which is an odd number. Okay, I knew the answer, but I wanted to eliminate. PAGP is a Cisco proprietary protocol. Then LACP, multiple vendors, including Cisco itself, can make use of that. Then in terms of my mods, start to end up my questions. I had my mods. What were the mods that we discussed in our last session on Ether channel for PAGP? What were the modes we discussed? So we have PAGP, and then we have LACP. I think both of them, they have on, what are the others? Quick. Yeah, why is making noise? What other modes we have? PAGP and LACP.
Desirable, auto.
All right.
Dynamic auto.
Desirable and auto. And this other side? Yeah, active.
Active.
And passive.
Passive, yes.
And what does on mean?
On it means the link is active, but it is not in forwarding state.
No negotiations. We've basically disabled negotiations. We are saying we are manually setting up Ether channel. So there is no negotiations there. Funny enough, it says on and there is no negotiations. Then this one active.
Negotiations are happening and also packets are being sent.
There is a word I'm looking for. These two negotiations are happening and packets are being forwarded. These two. What's the difference between them? There is a word I'm looking for.
You say the difference between auto and passive and active.
Yeah, the answer on the it applies to both active and passive, or desirable and auto.
Okay, so I think
Both of them, they have negotiations and their packets being exchanged there. But what's the difference between them?
For auto, it doesn't initiate the
I
negotiation
was
yet.
looking for initiation. Initiates, negos. So this one, no initiation. What's the opposite of initiation? And basically that's it. Then in terms of which modes forms ether channels, on and on definitely forms something. On and anything else doesn't form ether channel. So this one is okay. Then on and everything else, this is a no, nothing here. So nothing formed here. Then with desirable, we can have desirable and auto, they can form something. We can have desirable. I don't know why I keep saying desirable. Probably the French in me. Desirable and auto, desirable and desirable, yes. Auto and auto. What's happening? All right, auto and auto, 1 minute left. Auto and auto,
No.
from when channel.
No.
No, voila. So we are done with this. Let's answer some questions. What are the two requirements to be able to configure an ether channel between two switches? All interfaces need to work at the same speed? Yes. They also need to be in the same VLANs. They also need to have the same duplex settings. I think those three are key. So same speed, all interfaces need to be assigned to different VLANs. They should be the same. Different allowed range of VLANs must exist. All interfaces need to be working on in the same duplex mode. The interfaces that are involved need to be contiguous on the switch. What does contiguous mean? Chirungush. What does contiguous mean? I'm just curious. Contiguous. Getting a common border, touching. Okay. Or the interfaces that are involved need to be sharing an interface on the switch. I'm not so sure about this answer. I don't know what it's saying this one. Navarone Chirungu. 1 minute left. Join me in another session. I think we should be able to finish up this one.